All right, so today we're in section 8.6, scientific notation. Yesterday we started to lay the groundwork for this concept. We rounded to the leading digit, and then we wrote that number times a power of 10. How many place values were behind that digit? All right, so we're going to kind of expand on that concept today. The main difference between what you learned yesterday and what you're learning today is that we're not rounding the numbers anymore. We're writing all of our non-zero digits in the decimal value. So you know how yesterday we just rounded it to like the first digit? Now, if there's 3 or 4 numbers in that number, we're going to include all of those numbers in our scientific notation. So what is scientific notation? How many of you have learned scientific notation at some point in the past? Raise your hand. Like, most of you have not. All right. So it's a new concept. Day 1 of a new concept. You might get it. You might not. That's okay. Just do your best to follow along. Scientific notation is a shortcut to writing what? Really big. So we talked about that yesterday, right? Like the volume of the water on Earth or the diameter of a blood vessel. Really, really big or really, really small numbers. So instead of writing 82 zeros, I'm exaggerating, but instead of writing like all these zeros, I can write a number times a power of 10. All right, so we use powers of 10. Why? Does anybody remember why we use a power of 10? Why is 10 always our base? Does anybody remember? Nervous, awkward moment. Yes.
Isn't it like because of that rounding thing and like you round like?
Because of, it's 2 words. Place value. Thank you. Okay. Because of place value. Every place value is a power of 10. All right. Because once I get to 10 in one place value, it bumps the next one up by 1. Right. So I don't get to 8 and then I round it up. I get to 10 and then I round it up. So that's why 10 is always my base. Standard form is what we call the expanded. We can see the number with all of its digits. Scientific notation is the shortened version. This is important. I want you to circle, highlight something. The decimal value. So once we're moving this decimal, this is where the leading digit is going to help us. The decimal value has to be within the range of 1 and 10. Is 0.5 within that range between 1 and 10? No. Is 13 in that range between 1 and 10? No. So when I write it in scientific notation, my value has to be within that range. All right, that's going to be important when I'm moving my decimal to shorten up these really, really big or small numbers. All right, so let's look at first example. All right, example 1, I'm writing these numbers in scientific notation. So let's start with the top 2. All right, I'm going to try not to mess up my place value today. The first one is 173 million. Does everybody see 173 million? So my rule says, well, first of all, where is my decimal if I can't see my decimal anywhere in the original problem? Where is it? It's behind the last 0, right? It's behind the ones place. I want you to go ahead and put that decimal in there. That's going to help you visualize or see what we're doing here. All right? So I need to move this decimal somewhere in this number that gives me a value that would be greater than 1 but less than 10. So let's say I think I can move my decimal here. Is 17.3 greater than 1 but less than 10? No. So I can't move my decimal there. You're going to move your decimal after the leading digit. After the leading digit. So that's where what you learned yesterday helps you today. Move your decimal after the leading digit, from left to right, the first number that's not a 0. Is 1.73, is that value greater than 1 but less than 10? Yes. Okay. So now you have to multiply this by a power of 10, because we're not changing the value of the number. The value of the number is still the same. I should be able to convert it to scientific notation and convert it back to standard form without changing any values. So I decide what power of 10, this is really important, how many place values are now behind the new decimal from where it was originally to where it is now. How many place values are behind it? Okay? Does everybody see? 3, 6, 8. There's 8 place values behind it. Do not count the zeros. All right? Every year I have kids make that mistake. It's not how many zeros are there. It's how many place values are behind the decimal. So times 10 to the 8th power. Notice also, I included every value, okay? Every non-zero value is in my decimal. Don't put 1.7 and leave off the 3, right? Because if you do that, you're changing the value of the number. So we're not estimating this. Whatever numbers, whatever digits are in the original, you have to include those in your decimal. All right, how am I doing so far? Okay. All right, so what I want you to do now is do the next one, the 25 billion. Once you have the answer, I want you to turn to a neighbor and compare your answers with each other. Okay, so where did you move your decimal? Y'all tell me, where did you move it? Behind the 2. Remember, behind the leading digit gives me a value greater than 1, but less than 10. We always multiply it by a power of 10. Why?
Because the place value.
Because 1 power of 10 stands for a place value. So now I can just count how many place values are now behind my new decimal. How many place values are back there? Y'all tell me. 10. So that's why it's 2.5 times 10 to the 10th power. And this is my answer. This is the shortened way of writing it, scientific notation. That's all we're doing. Okay? All right, what do you notice about the bottom 2 numbers? What do you notice? They're decimals. They're really, really small, tiny numbers, right? So that's like our blood vessel example yesterday. But my rule is still the same. I have to move my decimal after my leading digit or my first non-zero number. That gives me a number greater than 1 but less than 10. So, Reese, where do you think you would move your decimal in that first number? Where do you think you would move it? Not in front of the 3, but behind the 3, which is, I think, maybe what you meant. But we're going to move it right back here behind the 3. We're going to make it 3.2. 3.2. Does everybody agree that number is greater than 1 but less than 10? If you moved it behind the 2, 32 is not in that range. That's the only place the decimal can go. All right? So now you need to decide how many place values, not how many zeros, how many place values did you move that decimal? All right? How many place values are in front of the leading digit? You moved it, let's count them. 1, 2, 3, 4, 5, 6. Now, if you remember yesterday, something has to be different about my exponent. What do I have to have? I heard it. Got to have a negative. The negative tells me that the number is really, really small. So if I'm the reader and I have no idea what the original problem is, that negative exponent tells me that the number is very, very small. Okay? What do you guys notice about this last one? What do y'all notice? There's 2 zeros and then there's a non-zero digit, the 7. All right? So remember what I said. We can't leave off a number that's not 0. So those 2 zeros in between, they have to be a part of my decimal, right? So I can't move it here after the first 0 and make it 50 because that's not between 1 and 10. I have to move the decimal after my first digit that's not 0, which is 5. But I have to have the 007 so I don't change the value of the number. Okay, so if there's zeros in between, you have to include them so you can bring in that last digit. What do you think the power is going to be? Does anybody want to raise your hand and tell me? What do you think the power is going to be? Tristan, what do you think? -4. I went 4 place values. Notice I didn't say 4 zeros, right? I went 4 place values to the right to get to my new decimal. Writing in scientific notation. What do you guys think? Any questions? So example 1, we write in scientific notation. What do you think we're going to do in example 2? Go back and write it in standard form. If you do this correctly, you should be able to go back and forth, and you're not changing the value of the number. Okay? So how do I know if I'm expanding my place values to the right or to the left? What do you think is going to tell me in here? What do you see between the two columns? The 2 on the left versus the 2 on the right. Sam?
The 2 on the left is positive exponent.
Yes. Very good. Do you notice that the 2 problems on the left have positive exponents? Do you guys notice that? And the 2 on the right have negative exponents? That tells you if the number, the true number, needs to be really big or really small. Y'all with me? Okay. So how do I know how many place values to expand my number by? Whether it's expanding it to make the number bigger or smaller. What do you think is going to tell you how many place values to expand it by? The power. The exponent tells me. So here's the common mistake. This exponent does not tell me how many zeros to add. Okay? Because there might be some place values already in the original problem. So what I want you to do is I want you to write the original digits. 3, 2, 2. How many place values are in the original decimal? How many are there? There are 2. So how many more place value holders or zeros do you need to make 5? 3 more zeros. So you're going to go 1, 2, 3. I want you to write the digits before you put any commas in there. And yes, I'm going to take off a point if you don't put the commas. Okay? The commas separate place values. So now go back from right to left and put in your commas. All right? We have the ones place, tens, hundreds. The comma goes after the 2. All right, so this is the expanded form. Does everybody see why I added the zeros at the end of the number? To make it bigger, because it was a positive exponent. All right, I want you to do this next one. 4 times 10 to the 6th power. Go ahead and do this one. So where are you going to add your place values? Do the place values need to come before the number or after the number? So look at your exponent and see if you can write the number. Someone raise your hand and tell me how many zeros did you add and where. So we need to expand this number. What did you do, Miley? Behind the 4 or in front of the 4? Okay, she added 6 zeros behind the 4. How did she know that she needed to make the number bigger? How did she know? The exponent's positive. Okay, the exponent's positive. So now that I have all these zeros, now I go back from right to left and I put in my commas. Did you put your commas in the correct place? Are your commas in the right spot? Okay, so there were no decimal values in my original problem, which is why I did add the 6 zeros, the 6 place values behind the number. All right, so we've already pointed out that the problems on the right have negative exponents. So where do you think you need to add the place values? Do you think you should add the place values in front of the number or behind the number? In front of the number. And what you're doing is you're moving that decimal. All right, so how many place values are already in front of the decimal? No, in front of the decimal. How many place values are here? There's only one. So how many more zeros do you need in front of the 7? 2 more zeros. So we're going to say 0 point. That first 0 does not count. 0, 0, 7, 9. All right? Think about this. Your original decimal was here. Do not have 2 decimals in your answer, so don't write this. But do you see how I moved it 3 place values to the left? All right? You cannot have 2 decimal points in your answer. You're moving the decimal. All right? Do you understand why we have 2 zeros in front of the 7? Okay? I want you to do the next one now. Write the next one in standard form. You have to decide how many place values you're adding in and where those place values are going. Okay, so go ahead and do that last one real quick. Okay, so Anna, how many zeros did you add into the number and where?
5 in front.
Okay, so she did 5 zeros in front of the 8. 3, 4, 5, 8, 3, 3, 4. Did you include all of the digits? 8, 3, 3, 4? Okay. Why did she add 5 zeros in front of 8 and not 6 zeros?
Because it was already.
Yeah, because you already had 1, right? And do I still have my decimal behind the 8? No, I moved my decimal. All right, that's how I'm writing it in standard form. You do not have 2 decimals in your number. All right, you're actually moving the decimal when you add those place values. Okay, how are you guys doing? Okay. So now let's talk about appropriate units. So this is just, again, we're talking very large units, very small units. What are going to be the most appropriate units? They throw this into this lesson. I don't know why, for whatever reason, but we'll cover it too. So what would be the most appropriate unit to use for a foot or one of those options? Foot, liter, milliliter, inch, and mile. Go ahead and just match them up. Do like a matching. So draw lines to what matches with each other. All right, Jonathan, what did you match with a foot? What did you do? D, the height of an adult? Okay, that's what I did. All right, Mason, what did you match with liter?
Buying soft drinks.
Yeah, buying soft drinks. Very good. Sam, what did you match with milliliter? Yeah, mosquito, right? Don't you guys love mosquitoes?
Oh, no.
Ugh,
No,
they're
I was gonna go
awful,
back yesterday.
awful. All right, what about inch? Inch, Gabe? B, length of an infant. Do you guys know how long you guys were at birth? Typically, no, you weren't. Typically, an infant is like between 19 and 22 inches long. So somewhere in that range. All right, what about mile? Last choice. Distance between Jacksonville and Orlando. So the most appropriate unit. All right, so why does this matter? Why did we're setting the stage, for example, 3. A female flea. Anybody have pets? You have to do the flea treatments. All right, so a female flea consumes about 1.4 times 10 to the 4th liters of blood per day. So we know that that's what fleas do when they bite our animals. They're actually taking in blood. All right, so a dog has 100 of these. 100 female fleas. Poor doggy. What is the total amount of blood consumed by the fleas each day? Here's where we need to use more appropriate units. Okay? All right? Is a liter, what do we say a liter was appropriate for? Like you're buying a soft drink. Do you think a liter is an appropriate unit to describe mosquito blood intake? No. So we're going to deal with that on the back side. All right? But for now, I want you to take this number and I need you to write it in standard form. We need to see this number completely expanded. So 1.4 times 10 to the negative 4th power. All right, go ahead and write that number in expanded form. So you have to decide where you're adding in the zeros. Are you doing it before the 1? The exponent tells you. Do you do it before the 1 or do you do it after the 4? Go ahead and expand it. All right, Tolanda, what did you put for that number?
The decimal point and then 3 zeros and 14.
Okay, and then 14. Do you guys agree with that? That negative exponent tells me the zeros go in front of the number. All right? But now, all right, so this is the amount of blood, okay, one female flea consumes. Look at the first statement. That's what I just did. One female flea consumes about this much blood. How do you think you could figure out 100? Times it by 100. Well, if I multiply a number by 100, remember, here's these powers of 10 again, right? How many powers of 10 is that? Is 100? 2, right? 10 times 10. So each power of 10 stands for a place value. So how many place values could I move my decimal? 2. To the right. I'm making it bigger if I'm multiplying by 100. I'm making it bigger. All right. So I have 0.014. Now here's the part that you're going to need to be taught. I'm just going to have to explain this to you. All right. This is liters. Hint on what we just did with the matching. What would be a more appropriate unit? Milliliters. Okay. So if I'm going from a big unit, all right, I want you guys to hold your hands up, like out wide, like you're giving someone a hug. If I'm going from a big unit, liters, to a small unit, so now move your hands closer together, I multiply. Big to small, I multiply. All right, we'll see how they do on the video for that. But yes, big to small, we multiply. So you said milliliters. Does anybody know how many milliliters are in 1 liter? Milla.
100.
1,000.
1,000. Yeah.
1,000. So you take this number, 0.014, and you're going to multiply it by 1,000. Well, if I just multiplied it by 100, all right, so this is what it looks like. 1,000 now, write this down, times 0.014. 1,000 is how many place values of 10? 3. Okay, so I move my decimal 3 places to the right, and I get 14 milliliters. Little m, big L. 14 milliliters. Okay, so that's a more appropriate unit. Not 14 thousandths of a liter. All right, a more appropriate unit would be milliliters. So that's going to take a little bit more practice. All right, you don't have to take a test on this tomorrow. Actually, your test isn't even until after spring break. All right, so I'm not going to worry about, I'm not ready to take a test. I know that, right? But you'll have a quiz next week. How did you guys do today, meaning that it's day 1 of ever doing scientific notation? Did all right? Okay, so that's going to be it for your lesson today.
You have homework, right?